In algebra and in other fields to which algebra is applied, we frequently work with equations involving more than one variable. Such equations are called formulas. For example, we have the formula for the perimeter of a rectangle. If we have a rectangle, four-sided figure, the opposite sides are parallel and equal, and the adjacent sides are perpendicular. We have four right angles in here. And if we designate the length by L and the width by W, the perimeter, let's say P, the perimeter of the rectangle, the perimeter being the distance around, is L plus W plus L plus W. The perimeter is the distance around the rectangle, L plus W plus L plus W, or P is equal to 2L plus 2W. Now, generally, we think of using this formula. We know L, we know W, we plug in L and W, and we find P. However, it might be possible that because of a certain application, we know P and we know L, and we want to find W. Of course, you can still plug in L and plug in P, and at the end solve for W. But if for some reason you wanted to perform this calculation several times, it might be more convenient to first solve the original equation for W and then plug in the L and P. Okay, now let's say we want to solve this equation for W. I just want to review for a second how we solve a first-degree equation. Let's say we were working out 3x plus 2 is equal to 11. Remember, the idea is that we would like to isolate, we want to solve for x, we want to isolate x alone on one side of the equation. We subtract 2 from both sides of the equation. We get, of course, 3x is equal to 9. We then divide both sides by 3, giving x equals 3. Okay, back over here, we would like to solve this equation for W. Okay, we want to solve for W. Now, when you wanted to solve for x over here, x was the only variable present in the problem, so we got all the constants over to the other side, and we solve for x. When solving an equation that involves more than one variable, the important thing is to remember which variable you want to solve for. Okay, we think of everything as either being a term with W or non-W term. The only important variable, although there are many variables in this problem, the only important one to us is W. We want to solve for W, so we want to isolate W. We want W on one side of the equation, everything else on the other side of the equation, even though they're variables. See, over here, there are all the other terms involve constants. We wanted to just solve for x. But if there are more than one variable, okay, keep in mind which one you're working for. You're working for W. You want to solve for W. The object is to get W alone and on one side of the equation. Okay, so P equals 2L plus 2W. Let's solve for W over here. P equals 2L plus 2W. The first thing we're going to do is to subtract 2L from both sides of this equation. Okay, now, over here, when we subtracted 2 from 11, they were both constants, and we can combine, and we got 9 for an answer. Over here, the best we can do is say subtracting 2L from P gives you P minus 2L. Okay, here, 2L minus 2L gives you 0. This is equal to 2W. Okay, don't be upset that you can't actually do any more combining than this. Okay, with constants, you could combine to get 9 here. It's just going to be P minus 2L. Then we're going to try to isolate W, so we'll divide both sides of the equation by 2, giving you P minus 2L over 2 is equal to W. Okay, and we have solved the original equation for W. So we now have this solve for W in terms of P and L. Okay, let's say we want to solve this formula for y. Solve for y, 6x plus 3y equals 9. We want to solve for y, so we want to get y alone and on one side of the equation. Okay, let's try to get y alone on the left. Let's subtract 6x from both sides of the equation, giving us 3y. 6x minus 6x gives you 0. 3y equals 9 minus 6x. then divide both sides of the equation by 3. Y equals 9 minus 6x over 3. This, by the way, is correct, but it's not in the lowest, it's not reduced, it's not in lowest terms here. We can factor a 3 out in the numerator, leaving us with 3 minus 2x. Multiplying this is 3 times 3, that's 9 minus 6x. That works. So this is 3 times 3 minus 2x over 3, and now we can cancel the 3's, giving us a final answer of y equals 3 minus 2x. Okay, you had the answer at this point, but it wasn't in lowest terms, and now we have the final answer, y equals 3 minus 2x. Okay, let's try to solve this equation, a equals 1/2 bh. Solve this equation for h. By the way, this is the equation which gives the formula which gives the area of a triangle. You'll be studying this later on when we get to our videotapes on geometry. If you have a triangle, okay, and B represents the base here. H is the height, which is the perpendicular height. Okay, the length of this altitude. Okay, the perpendicular distance from this vertex to the base. Okay, the area of this triangle is 1/2 the base times the height. Okay, we'd like to solve, you don't have to know what it is the formula for, but in order to solve it for h, I just wanted to show it to you. Okay, we want to solve for h. We want to get h alone and on one side of the equation. Okay, first thing we notice that there's a fraction. Well, we can proceed the same way we always do with fractional equations. We can get rid of the fraction. We will multiply both sides of this equation by 2. Okay, we multiply the left side by 2 and the right side by 2. Okay, this gives us 2a. This is really, of course, 2 over 1, and the 2's here cancel. We have 2a equals bh. 2a, the 2's cancel, equals bh, and to solve for h, we divide both sides by b, giving us h equals 2a over b. Okay, let's try one more example. We want to solve for x. And we have ax plus b equals cx plus d. Okay, and for the first time today, we see that the variable that we want to solve for appears in more than one term. Okay, still, each time the variable appears, it only appears to the first power. Okay, and what we're going to do is get all the terms with x on one side, all the terms without x on the other side. Okay, so let's subtract cx from both sides of the equation, giving us ax minus cx plus b equals d. Don't do more than one thing on each step, okay? We're subtracting cx from both sides of the equation. Always keep in mind where the equal sign is. Okay, a common mistake is, say, to do the subtraction, both subtractions on the same side. Okay? Make sure that you're subtracting the same quantity from both sides of the equation. ax minus cx plus b equals, here, cx minus cx is 0, equals d. Okay, now we want to get the terms with x alone on one side, so we have two terms with x. This term doesn't have x, so we will subtract b from both sides, giving us ax minus cx equals d minus b. And we can factor out an x, okay? Here, x times a minus c equals d minus b, and divide both sides of the equation by a minus c. We're assuming that all these divisions are possible, that a is not equal to c. Otherwise, we'd have division by 0. And we get final answer. The a minus c's cancel. We get x equals d minus b over a minus c. By the way, a common mistake in solving this problem for x, okay, people say work it out like this. ax plus b is cx plus d. They start off by subtracting b from both sides. Get ax equals cx plus d minus b. And then they think it's enough just to divide both sides by a. Because after all, they say, look, we've got x equals. Okay, what's wrong with this idea, okay, is that x has to appear alone and on only one side of the equation for you to be finished. Here we have x equals cx plus d minus b over a. In other words, x is on both sides. You haven't solved for x if x is on both sides of the equation. Okay, so this is not the way to proceed in this problem. Okay, we must get x alone and on only one side of the equation. And that brings us to the end of this tape.